nose of the feed plate, it is also selected according to the length of the fiber. In draw frame, speed frame and ring frame, the nip to nip distance depends on the length of the fiber. Longer length requires wider setting, the shorter requires a closer setting. If for longer fibers we are keeping the setting closer, the breakage of the fiber will take place, the swing effect will be there. And if the setting is wider, then the floating fibers will cause the drafting waves and ultimately the performance of the yarn in blooms and subsequent processes. So, apart from the settings, apart from the speeds, one of the parameter, that is the twist in the ring frame, it depends on the length of the fiber. Longer the length, less TPI will be required to get the same strength which we want to get from the short fibers. So TPI is affected by that. So we are having different methods: direct methods, semi-direct methods and indirect methods. In direct methods, we are using the single fiber test, then the hand staple method, then the Baer Sorter diagram, then the shell-less sorter, and in semi-direct, the ball/slash sorter is there. And the indirect system, the fibrograph and the HVI, these are the methods. And we have seen also that the Baer Sorter diagram, it gives us the exactness of the length. But friends, this requires time, this requires skill. So training is one of the important part while preparing the Baer Sorter diagram. Now the comb is there, the 20 milligram sample is there taken, and then when we draw the fibers from the comb and put it on the velvet black piece, then the diagram which is available to us is OAB. Now how to analyze the effective length, short fiber percentage, mean length? Now Q is the midpoint of OA. OA reflects the fiber length in millimeter, while the horizontal axis, it affects with the percentage of fiber. Then from Q, a line is drawn parallel to OB where it cuts my diagram at P dash. From P dash P is perpendicular to OB. Then OK is 1/4 of OP, and from here another perpendicular is drawn K, which cuts my curve at K dash. S is the midpoint of my KK dash. From here a line is drawn perpendicular to OB which cuts my curve at R dash. Then R dash R is perpendicular on OB. OL is 1/4 of OR. From here another line is drawn, perpendicular line which cuts the curve at L dash. Now sir, effective length is LL dash. The percentage of short fiber is RB upon OB into 100. And main length is area under OAB divided by OB. So friends, from this diagram, we have calculated the effective length, Now the effective length is given by the length of the line LL dash, and this is the length which is defined as the main bulk of the longer fibers. Now this is the length. Why it is called effective? Because this is the length where that many machinery settings are relating. Mean length, this is the average length of the fibers in the sample, and percentage is short fiber. This is the percentage of fibers, the length of which are equal to less than half the effective length. So friends, as you have seen that from the Baer Sorter diagram, we have calculated the different parameters, and we can use these parameters in finding out the comber efficiency, that is the fractioning efficiency, how much improvement in the mean length there by the comber. We can study the breakage of the fiber in the comber process, or the blow room process, and with this diagram we can adjust the setting, that because effective length is the main parameters with the help of which we adjust the nib to nib testing. So the analysis of the Baer Sorter diagram is very important for a quality control in charge, quality control officer, and the people who want to do research and development work. Thank you friends. Have a nice day.